In this video, we will be talking about regression. We will review linear and quadratic regression, and then we will talk about cubic and quartic modeling or regression. So most of everything that we'll do in this section will be done in Desmos, and I have most of everything typed in already. Just mainly these equations here, and then I'll type in the tables with you. So you're going to need your Chromebook and you're going to need Desmos open to do this part of the notes. I want you to follow along because there are lots of steps here and it can get confusing. So number 1 says the data below shows the average student loan debt accumulated by college graduates during certain years since 1996. So 1996 is year 6 because we're going to start with 1990 as our baseline. So year 6, because I can't type 1996 in my table. It won't work. It will give me an error every single time. So our goal is to write an equation for the line of best fit and then estimate the average student loan debt for a student graduating in 2020. So 2020 is going to be 30 years after, it's going to be 30. So X will be 30 in that case, because this is X and this is Y. 2000 will be year 10, because that is 10 years after 1990. And then 2004 will be 14, 2008 will be 18, and 2009 will be 19. We can still type in these loan debt numbers. We just can't type in the years because they don't like it. Desmos gets angry. So, let's go to Desmos. So let's type in our numbers 6, 10, 14, 18, maybe, and 19. And here I already have all of my little functions here typed in just to make it, because they are tedious to type in. If you need help typing them in, since I didn't type them in on the video, come see me and I'm be more than happy to help you type them in. The thing down here with the quartic one, this one, you just can't use the letter E because that plots your residuals, which you don't care about. So, and then this is where you turn these guys off. So that we wanted a linear line of best fit, so I just turned off all the other ones so we don't get so many things popping up. And somebody asked for slow jazz, so I put slow jazz on in the background. I hope that's okay. Then you can listen to it while I'm typing. Alright, so I want to so this is my line. It's like almost vertical. Well, that's okay. So what I care that it looks like that, but not. So this, if I undo that. So this little magnifying glass down here in the bottom left-hand corner of my table box, if I hit it, it takes it so I can zoom out and see my line and my points in a nice scatter plot thing with a line of best fit. So this here, this one right here, tells me my parameters. Not that one, this one, the one above it. Excuse me. Tells me my parameters. So it tells me A is 830.285, and then B is 8064.18. So that's where this comes into play. So we're going to go back to our paper, and we're going to write that down. So f of x, or y, equals 830.29, just to round for nice, and plus 8064.18. And I want to determine or estimate the average student loan debt for a student who is graduating in 2020, or in this case, year 30. So I want to find f of 30, and when I plug that in, I will get $32,972.88. So if you were to graduate from college in this year, 2020, the average, according to this data, your average student loan debt would be almost $33,000. So that's just a quick review of linear. Now to move to quadratic. So Dan hit a golf ball from the top of a hill. The height of the ball after each second is given in our table below using a quadratic model, which here's my quadratic model. Write an equation for the curve of best fit and then estimate the height of the ball after 5 seconds. Okay? So this is x and this is y. So let's go to Desmos and type it in our table. So you can just delete this table, then add a new table. But I have a bunch. I need x to the first and y to the first, just for it to work nicely. So 0, 1, not 11. 1, 2, 3, 4, 60. So this is where that little magnifying glass comes in handy. You can see that our linear, I never turned it off, but it doesn't work for this set of data. So I can click it off and then I know it's quadratic, so I can make that go. And this is as close as I will get. And down here I have A, B, C, and D. Not D, A, B, and C. I don't have D yet. We hadn't made it there yet. So there is A, B, and C. So I'm going to go back to my notes and write it down. So f of x equals negative 8.29 x squared plus 32.74 x plus 59.83. And I want to find the height of the ball after 5 seconds. So I'm going to find f of 5, which will give me 16.28 feet when I plug it in. So all you're doing is plugging in 5 for x. So that is a quick review of linear and quadratic. So now we're going to move into cubic and quartic functions. So our cubic is our x cubed, x to the third power, and quartic is x to the fourth. So just a tip when you're doing this, don't use e. Just again, don't use e in the equation. So the Millennium Force, which I guess is a roller coaster at Cedar Point in Ohio, shows the average number of people in line at each hour after the park opens. So we're going to use a cubic model, to find the equation and then estimate the number of people in line 6 hours after the park opened. So we're going to type this into Desmos. So I'm just going to clear this one out instead of changing a new one. Because I only need... And I'm also going to unclick my... I'm done with my linear and my quadratic regression, so I'm going to take them out. So just, if you're wondering where they went, they disappeared because we're done with them. We're not necessarily done with these, though. So once again, you can hit that little magnifying glass, and then you can turn on your cubic. There you go. Now you can see it a little bit better, that it is a cubic. And there are your lovely coefficients here, A, B, C, and D. We do have a D this time, instead of last time when I said we did and we didn't. So we're going to go back to our notes, but we want to estimate when it's 6 hours. So just so we're thinking about what we want to estimate. So let's go back to our notes and write down the equation. And I just rounded 2 decimal places because we don't really need more than that. So there's my equation, and I want to estimate when x is 6 or 6 hours. So there would be 75 people when you plug it in. And you can just plug that straight into your calculator. Or you can plug it into Desmos if you want to write this equation out in Desmos. Alright, we are going to do one more equation. I know there are more than that on your paper. However, we're just going to do one more. We're going to do the quartic one. So on the first day back to school after winter break, 20 students were absent from school because they were sick. So we want to determine the curve of best fit using the equation and estimate the number of students 9 days after break. So here's our table. Here's our table. So let's go back to Desmos, our best friend. So we're done with cubic. And let's deal with these guys. So there's my function with my curve of best fit, and there are all my lovely coefficients of my x's and my constant. So go back to our notes. And write out our equation. So we want to determine the number of students absent after 9 days. So f of 9, which would give me 26, which is 26 students. So the thing with 5 and 6, once again, they are years. So I'm not going to do them, but I will give you how you would do this. So you since 1950 for number 5. So you'd start with 5, and then you'd go to 11, because 61 is 11 years after 1950, and so on down the line. And then you want to determine the wage in 2025, which would be x equal to 75. Same kind of idea as 6. You want to determine the stock index since 1988. So 88 would be year 0, 90 would be year 2, and then you can go on from there. But for these, you do need both the equation and the number that you're estimating to get full credit.